Welcome to FAULABR Drive Time. In this video, I will show you the most common error when dealing with a brushless motor. We will use some instruments like a multimeter to check the feedback signal properties. This is important to identify potential causes of motor malfunctions. Brushless motors are three-phase systems which need electronic commutation because they don't have a brush and a commutator like DC motors. They need an external drive electronics which need the rotor position information from an encoder or from a Hall sensors to correctly perform the electronic commutation. Let's have a look at the main error to avoid using brushless motors. A typical motor problem is the motor heating up while the rotor is blocked. Under this condition, the winding is heating up and its temperature may reach the thermal limits. After some minutes, the motor may be damaged. If you realize that the motor doesn't work as expected, power off and check the cause. It could be either mechanical or electrical. The first thing to check before power on is always the connection of each motor wire to the drive electronics. Using FAULABR speed or motion controller, a series of adapter and specific cable for each motor and sensor type are available for safe direct plug-and-play operation. If you are using a third-party motion controller, you must refer to its specific instruction manual for motor connectors information. Again, the matching of pin assignment is important. In the FAULABR website, you can find a suitable application note for third-party drive electronic connection. The most frequent error comes from incorrect motor wiring. Always refer to the pin assignment for each motor wire, also described in a color-coded form published in the motor datasheet. The three motor phases must be correctly plugged at the controller side and on the corresponding phase position. The supply wires and the three Hall sensor output must be connected to the corresponding sensor position. Some applications may need sensorless operation. In this case, just use the three-motor phase connection. The drive electronics commutates the current into the motor phase, depending on the Hall signal value, to move the rotor in a defined position. When you invert two-phase line, there is a wrong current commutation sequence. The rotor then will shake or get stuck, and the temperature of the winding will rise dangerously. The same problem happens with the inverted Hall sensor wires. Since the drive electronics apply the next commutation switch based on the Hall sensor information, wrong rotor position information can cause the motor malfunction. So, check the motor wiring. If you are designing your own drive electronics, we recommend to limit the motor current way below the stall value to protect the winding from overheating. A suitable value for continuous operation is the rated current published on the motor datasheet. With good heat dissipation, the value can be higher. Digital Hall sensors have an open collector configuration. This allows for using supply voltage up to 24 volts, but for the correct voltage detection, it is necessary to connect a pull-up resistor between the output pin and the supply voltage. Otherwise, the signal will be detected incorrectly. Another cause of malfunction is the sensor damage. Well, it's not so difficult to damage a Hall sensor. Electrostatic discharge during handling, supply polarity inversion, and the wire connection to the controller phase output may severely damage the sensor output, and the motor is not usable anymore. Once again, the wiring check is important, especially to avoid sensor damage, which is not repairable. How can you check the Hall sensor signal? Well, you need a multimeter. You have to plug correctly all the wires to the drive electronic and measure the sensor output voltage while you rotate the shaft manually. You can see that the value is variable from 0 to 4 volt. And if you see a continuous voltage during the rotation, then the Hall sensor output is damaged. In other motor, analog Hall sensor must be powered with only 5 volt DC. Over this voltage, you may damage the sensors. The output signal must vary in the range about 1 to 4 volts, typically. With long wires, you can experience bad motor control with unwanted vibration and noise. Long wires act like antennas, collecting electromagnetic noise from the radiating source in the application. Noise affects especially the analog Hall sensor signals, and the motor control may become unstable because of bad signal quality. To avoid this, the use of shielded wire is recommended. The shield collects noise from the sources, and it must connect it in a suitable way to the protective earth of the application wiring. On the faulhaber website, there is an application note on shielding and grounding of motor wires. Have a look at it, it's very interesting. Possible cause of vibration and noise coming from the motor could be also related to wrong motor selection in the configuration phase using faulhaber speed or motion controller with the Motion Manager software. Always choose the correct motor and the correct winding voltage to get the best motor control. A potential damage may happen when you move by hand a mechanical system driven by a motor combined with a gearhead. Depending on the reduction ratio, the motor may generate high voltage which may damage the drive electronics and other devices connected to the supply line. If you must move manually, the mechanics connected to such drive system disconnect the motor wires before any move and move slowly. A frequent error is the use of wrong screw length during motor mounting in the application. Long screw may easily damage the winding which is just behind the mounting flange. Please always refer to the mechanical drawing published in the datasheet and use the correct screw length. You can see here clearly the damage due to the longest screw that damaged the winding, and in this case you can see that the long screw damaged the drive electronics inside the motor. So take care and be careful when you use long screw. To conclude, always refer to the datasheet information to avoid wiring error and damage to the motor. Thank you for watching this video. Check out our other videos on faulhaber drive time. Feel free to leave a comment below. Take care. Goodbye.